Hello students, by this video let us study about the radial distribution function for 1s orbital, 2s orbital, 3s orbital and 3d orbital. So when we know what is orbital, so by previous video we understood the complete details about the radial distribution function, the wave function, the two parts of wave function, that is the radial distribution function and angular distribution function. So that we all studied about the definition for orbital, right? Now in this video we will just see how the graph is plotted for 2s orbital, 3s orbital and 3d orbital. Fine. So first we should know what is orbital. So fine. So orbital is the three-dimensional space where there is maximum probability of finding the electron around the nucleus. Right? So this we have already seen before. So 1s, 2s, 2p, 3s, 3p, these all are different orbitals. Understanding? Yes. So 1s orbital, in this 1s orbital, 1 is the 1, 2s orbital, 2p orbital, 3s orbital, 3p orbital. So in all these values, the first value, these numbers, they indicate the principal quantum numbers. Okay. S, P and S, P, D, F, they are the orbitals. Okay, S orbital, P orbital, D orbital and the F orbital. Yes. Now, by using the value of n, we can write the value for L. N is your principal quantum number and N is your azimuthal quantum number. When the value of n is equal to 0, I mean the azimuthal quantum number value n is equal to 0, then that indicates the s orbital. When the value of n is equal to 1, then it is p orbital. Then when value of n is equal to 2, that indicates d orbital. When value of l then is equal to 3, then it is f orbital. Fine. So from these orbitals we can find out what is the principal quantum number and what is the azimuthal quantum number by using this orbitals. Okay. So, well, in the previous video we have already studied of plotting the graph for 1s orbital. So 1s orbital, while plotting the graph, we take on the x-axis the radius. Radius is in the Armstrong unit. Radius is always in the Armstrong unit. Okay. Versus 4 pi r squared into r squared. Okay, so this 4 pi r squared is nothing but the area of the sphere. Yes, area of the sphere, and r squared is nothing but your wave function. Radial distribution, radial wave function is r squared. Okay, so radial distribution function is the product of area of the sphere and r squared. Okay, so radial distribution function is the product of area of the sphere and r square. So r square, that is your radial wave function. Okay, so we know psi square. Psi square is nothing but your probability wave function. Wave function where the probability of finding electron is maximum. That is your psi square. Right. So that wave function. So that wave function is represented in the case of radial wave, so that is r square. Got it? Now let us plot the graph for each orbital, like 1s orbital, 2s orbital, 3s orbital, 3d orbital. Right? Now on the x-axis radius is taken, and on the y-axis 4 pi r squared is taken. Okay. So when the radius is 0, there is maximum probability of finding the electron near to the nucleus. Okay, so this r square, this is the wave function. Radial wave function, it is r square is radial wave function. So when the radius is equal to 0, you can see you get a curve like this. The curve is like a peak, narrow peak. Okay, so this peak, this is the maxima. So maxima means when the radius is equal to 0, there is maximum probability of finding electron around the nucleus. So that maximum is this peak. So this peak indicates it is maximum, that is probability of finding electron is maximum in this peak. Okay, so as the radius increases, what happened? This probability wave function psi square or r square, that keep decreasing. Okay, so to the peak it comes, to the maximum level it comes, and then from again it decreases as the radius increases, and finally it reaches to 0. Understanding? So this, now here when you join this peak, from this peak to by dotted lines, when you join to the x-axis, so that radius is something 0.52. So at the 0.52 radius, there is maximum probability of finding electron around the nucleus. Okay, so that's what this peak indicates here. So this maxima indicates that. So this 0.52 radius is your Bohr's radius. Understanding? So this is the graphical representation or graphical plot for 1s orbital. Okay. Now let us look into the 2s orbital. Okay. So in 2s orbital also we take radius in the Armstrong unit as the x-axis and 4 pi r squared r squared the radial distribution function as the y-axis. Okay. Then, so here you can see there are the way goes starting from 0, it goes to the maximum value, and then again as the radius increases, it comes down, the curve comes down, it touches the 0, and then again from there again it goes up maxima, and then again it comes down. Okay, so in the case of 2s orbital, you can see two maxima. This is 1, 2. So two maximas you can see in the case of 2s orbital. Okay, now this curve, it goes to the maximum and then comes down and touches 0. So this point is called as the nodes. This point is called as a node. So the point where it touches the 0, that means there is no electrons. You can't find any electrons at this particular radius. Understanding? So the place where there is no probability of finding electrons, so that is this nodes. Understanding? So what is node? Node is the point around the nucleus where there is no probability of finding electron. Okay, radius is S. So at this radius, at this particular region, there is no probability of finding electrons. Understanding? So that is nothing but your node here. So in the case of 2s orbital, there are two maxima and one node. Okay, two maxima means the probability of finding electron is maximum, whereas in the node, the probability of finding electron is 0. You don't find any electrons at the nodes. Understanding? So in the case of 2s orbital, there is two maxima and one node. Okay, now let us look at the 3s orbital. So 3s orbital, how is the curve going? From the 0 it starts, from 0 it goes up to the maxima, S, a small maxima, and then again it comes down to the x-axis, S, then from x-axis again it goes up to another maxima, S, and then again comes down, then from here again it goes up to another maxima and it comes down. Yes, so in the 3s orbital, the graphical plot of x-axis is radius and y-axis is our radial distribution function 4 pi r squared r squared. Okay, so here the curve represents three maximas, 1, 2, 3, three maximas, and here you can see how many nodes? 1, 2, 2 nodes. Okay, so in the case of 3s orbital, there are 2 nodes and 3 maximas. Okay, so probability of finding the electrons is maxima. So here in the case of 3s orbital, 3 maximas are there. Okay, and the nodes where the probability of finding electron is 0, so they are nothing but the nodes. So at this radius, the probability of finding electron is 0. Okay, so that is nothing but your node. So in the case of 3s orbital, 2 nodes are there. These are the nodes, 2 nodes are there. Okay, now looking to the 3D orbital. So 3D orbital, you can see just one maxima, just one curve, yes, so that is maxima here, just one maxima. Yes, so is there any nodes here? No nodes here, there is no nodes at all. So at this particular radius, the probability of finding electron is maxima. Now in this case, at this particular radius, the probability of finding electron is 0. that is nothing but your nodes. So in the case of 3D orbital, there is no nodes but only one maxima. In the case of 3s orbital, there is 3 maxima and 2 nodes. In the case of 2s orbital, 2 maxima and 1 node. Whereas in the case of 1s orbital, only 1 maxima and no nodes. Okay, so 1s orbital means the first shell. 1 represents the first shell. S means s orbital. Okay, so first shell orbital, that is 1s orbital, will be near to the nucleus. So probability of finding nucleus is maximum. There is no nodes there. That means you can find electron around the nucleus in the first shell 1s orbital. Okay, so there is a particular formula to calculate the radial nodes. So these nodes are called as radial nodes because it is radial distribution function. The nodes we call it as radial nodes here. So there is a particular formula to calculate the radial nodes. So that is n minus l minus 1. N minus l minus 1. Okay, so we can calculate the nodes for each orbital easily by using this formula n minus l minus 1. Now let us calculate the nodes for each of this orbital by using formula. So from the graphical representation, we can calculate the number of nodes and maxima, right? Now here we just by using the formula we will calculate the number of nodes, that is the radial nodes, by using the formula n minus l minus 1. Okay. Now for 1s orbital we will calculate. Well, what is value of n here in the 1s? N is equal to 1. So 1 minus, what is the value of L? In the s orbital, value of L is equal to 0. Okay, so 1 minus 0 minus 1. Yes, so 1 minus 0 minus 1 is what? It is 0. Okay, so nodes, is there any nodes in 1s orbital? No nodes. That means 1s orbital, number of nodes is 0. Okay, now let us go to the 2s orbital. So 2 minus. So what is the value of L in the case of s orbital? S orbital is 0. Yes, 2 minus 0 minus 1. So 2 minus 1, it is equal to 1. So 2s orbital, there is only one node. So you can see here in the graph 1. Okay, got it? Now let us take the 3s orbital. 3 minus L value for s orbital. For s orbital value is 0. 3 minus 0 minus 1. So it is equal to how much? So 3 minus 1, so it is equal to 2. So now look into the 3s orbital. How many nodes are there? 1, 2. So 2 nodes are there. Yes. So the node is also 2 nodes are seen here. Okay. Now we will take it for the 3D orbital. So 3D orbital 3 minus s. What is the n value for the orbital? 2. So 3 minus 2 minus 1. So 3 minus 2 is 1. 1 minus 1 is equal to 0. So here you can see, is there any nodes here? No nodes. So like 1 maxima is there. Fine. So now the formula what we calculate, the number radial nodes. So that is similar to that of the graphical representation nodes, right? Yes. So that's it all about your radial distribution function. So here you have to keep in your mind these different graphical plots. You have to keep studying well, and also the formula. So for any orbitals, 3s, 3p, 3d, like that, for any orbitals you can just calculate the number of radial nodes. Fine. So hope you understood this video. Thank you.